In this lesson, we'll start digging into the basic ladder instructions. If this is your first time watching this series of videos, we highly recommend that you start at the beginning, since each lesson builds on the previous ones. Here we've highlighted the basic instructions that we're going to cover one by one over the next 3 lessons. These little things in the program that look like electrical schematics are called instructions because they tell the PLC processor what to do. We'll start with this one, which is the most basic instruction of all. First of all, we'll need a name for it. We'll use XIC since that's how it's listed in the official books. So now we have a name, but the bigger question is, what does it do in the program? We've been asking students, what does this thing do, in our boot camp classes for about 20 years now, and here are some of the most common answers that they've come up with. And the sad truth is that every one of these rules is either completely wrong or else it's so confusing and misleading that it's not much use at all in a troubleshooting situation. So now the question becomes, if all of the answers on this list are either wrong or misleading, then what's the right answer? And believe it or not, the correct answer will fit right into this one little box. Go look for a 1. No joke. Once you understand this one simple little rule, then you can throw everything on that confusing list away and finally start to really understand PLCs. I always get a kick out of watching the more experienced students in the class the first time I describe the XIC this way. Some of these guys have many years of experience, and they just know that there has to be more to it than this. Well, we're going to work through some examples in these preview videos and prove that it is just this simple. But first, let's clear up some of the most common misconceptions about what the XIC instruction does. And there are a lot of mistakes and misconceptions about this simple little thing. First of all, since it looks like the schematic symbol for a set of switch contacts, many people fall into the trap of thinking about it like a real switch out in the field. That's wrong. Quite a few people imagine that the XIC is somehow or some way wired up directly to a switch in the field. In fact, the official name, examine if closed, is very misleading because it seems to refer to electrical contacts that could be closed or open. Forget about the contacts. Instead, concentrate on the fact that the XIC just tells the processor to go look for a 1, and the place where he'll go and look will always be a bit box located right inside the processor. Now let's dig deeper. If we're telling the processor to go, then we'll also need to tell him where to go, and that's what the address over the instruction does for us. And the address will always have to be a valid address of a bit located right inside the processor. And we've already learned that a bit is a box that can hold either a 1 or a 0. Now we come to a very common misconception. Some students, even some with years of experience, have the idea that the address has something to do with how the XIC acts. That's wrong. Here are some examples of different types of bit addresses. The truth is that whether you use an input address or an output address or any other type of address, none of those addresses make any difference at all to the way the XIC acts in the program. In other words, the XIC instruction always just tells the processor to go look for a 1. Nothing more, nothing less, no matter what type of address you give it. Here's a very common rung construction, one that we'll talk more about in another lesson. Many experienced technicians call this a seal-in type rung. And here are some common misconceptions to go along with it. A lot of people think that the XIC at the top of the branch works like a start button and acts one way, and that the XIC in the bottom of the branch works like a seal-in contact and acts another way. In other words, they think that the position of an XIC in the rung decides what action the XIC will take. That's wrong. Let's highlight these 2 XIC instructions and compare them with each other. This one was located at the top of the branch and has an input address. This one came from the bottom of the branch and has an output address. But no matter what many technicians believe, both of these XIC instructions do exactly the same thing. In other words, all any XIC instruction ever does is tell the processor to go look for a 1, period. It really is just that simple. Now let's nail all of this down with a few examples. Here's an XIC instruction and some bit boxes in the processor. And notice that there are no switch contacts for the XIC to examine anywhere in this sketch. That's because the XIC doesn't work with switch contacts, only with bits. Now then, let's suppose that the processor has just come across this XIC instruction in the program. The rule says that he's got to go look for a 1. The address tells him that he's going to look in the bit box named switch A. So the processor goes and looks in the bit box named switch A. Does he see a 1? And the answer is no. So the processor goes back to the XIC and marks it as a false condition. Notice the little F underneath. And now he's done with the XIC for this pass through the program. That was simple. Now let's work another. When the processor comes to this XIC in the program, the rule says that he's got to go look for a 1. The address tells him that he's going to look in the bit box named O:001/1. Now that just happens to be an output address. Does that mess anything up? No, not at all. To the XIC, it's just another bit box. So the processor goes and looks in the bit box named O:001/1. Does he see a 1? And the answer is yes. So now the processor goes back to the XIC and marks it as a true condition. And now he's done with the XIC for this pass through the program. And one more. When the processor comes to this XIC instruction in the program, the rule says that he's got to go look for a 1. The address tells him that he's going to look in the bit box named T4:0/DN. Many students already know that this is a timer's done bit, but to the XIC, it's just another box. The main thing is that the PLC processor doesn't know or care about what the bit means. He's just looking in a box for a 1. It really is just as simple as that. So the processor goes and looks in the bit box named T4:0/DN. Does he see a 1? And the answer is no. So now the processor goes back to the XIC and marks it as a false condition. And now he's done with the XIC for this pass through the program. So, summing up, here's the XIC instruction. It's an instruction or a command from the programmer to the PLC processor. The instruction tells the processor to go look for a 1 in a bit box. If the processor does find a 1, then the XIC will be considered true. If the processor does not find a 1, then the XIC will be considered false. The XIC always needs a valid address to tell it which bit box to go look in. The bit box will always be located inside the processor. No matter what anyone tells you, the XIC cannot look at or examine a switch out in the field. That's because the XIC has no way to look outside the processor. Naturally, in these short videos, we don't have time to go through all of the common misconceptions on this list, but a lot of what we do in our boot camp approach is find out what type of mistakes the students already have stuck in their heads. Then we weed that incorrect information out and replace it with straightforward facts and simple rules to make PLCs perfectly understandable. Just remember that the XIC always tells the PLC processor to go look for a 1, and you'll be in good shape. The switches and contact analogies that you might have learned in other classes are just beginner stuff. You'll see the differences for yourself when you take one of our classes, because we'll always prove that everything we teach is correct, usually by just wiring up a few simple switches and light bulbs. But for now, here are the 3 basic instructions that we've set out to cover. Here's the one we've just nailed down, and now we're ready for the next lesson.